Let's look at cylinder blocks. The cylinder block is the largest part of the engine. Its upper section carries the cylinders and pistons. Normally, the lower section forms the crankcase and supports the crankshaft. It can be cast in one piece from grey iron, or it can be alloyed with other metals like nickel or chromium. The iron casting process begins by making up the shapes of what will become water jackets and cylinders as sand cores, which are fitted into moulds. This stops these parts becoming solid iron. Molten iron is poured into sand moulds that are formed by patterns in the shape of the block. After casting, core sand is removed through holes in the sides and ends, leaving spaces for the cooling and lubricant passages. These holes are sealed with core or Welsh plugs. The casting is then machined. Cylinders are bored and finished, surfaces smoothed, holes drilled and threads cut. All cylinder blocks are made with ribs, webs and fillets to provide rigidity, but also to keep weight to a minimum. As more manufacturers try to make vehicles lighter and more fuel efficient, more and more engine blocks are being cast from aluminium. A block made of aluminium alloy is lighter than if it were made of cast iron. So if two engines are generating the same power, the alloy version would have a better weight-to-power ratio than the cast iron version. Aluminium alloy blocks are made by various casting processes, including pressure casting. Another method is gravity casting, where the molten metal is poured into moulds. Cast iron liners are usually used in the cylinders of aluminium blocks, and sometimes in cast iron blocks. Some sleeves are cast into the block. Grooves on the outside form a key that stops any movement in the cylinder. They also increase the surface area to assist heat transfer from the sleeve to the block. Some blocks don't need liners. They can be made of wear-resistant material that makes a hard-wearing surface for the pistons and piston rings. Or the cylinder bore may have some sort of surface treatment to make it hard-wearing. When the cylinders, block and crankcase are all cast together, it's called a monoblock construction. This is called a horizontally opposed block. It has a split crankcase. The two engine blocks are joined together by the flanges of the crankcase. In air-cooled engines, the cylinders are usually made as separate parts, then bolted to the same crankcase. Each cylinder has cooling fins. They're often machined to give uniform thickness and allow free flow of air. This section examines cylinder heads. The cylinder head bolts onto the top of the cylinder block where it forms the top of the combustion chamber. Inline engines of light vehicles have just one cylinder head for all the cylinders. Larger inline engines can have two or more. V-type and horizontally opposed engines have a separate cylinder head for each bank of cylinders. Just as with engine blocks, cylinder heads can be made of cast iron or aluminium alloy. A head made of aluminium alloy is lighter than if it were made of cast iron. Aluminium also conducts heat away more quickly than iron. So with an aluminium alloy head, the heat of combustion can be conducted away into the coolant more quickly. Manufacturing the head is similar to manufacturing the block. A casting mould is made. Sand cores are put in to form any hollow areas. Depending on the engine, These can be for coolant and lubricant passages and inlet and exhaust ports. Air-cooled engines have cooling fins cast into the cylinder head. The underside of the head is shaped to form the combustion chamber. Molten metal is poured in and allowed to cool. The cores are broken out and removed, and the cylinder head cleaned of any sand. After casting comes machining. Surfaces that must seal are machined flat. Holes are drilled and tapped for attaching bolts and studs. In sand cast heads, the large holes that had contained sand are machined, then fitted with soft metal plugs called core plugs. This section examines the crankshaft. The crankshaft is attached to the connecting rod in offset areas called throws, where the downward power pulses change into rotating motion. Crankshafts must be strong enough to do this without bending or twisting. They are a one-piece casting or forging of heat-treated alloy steel of great mechanical strength. Counterweights are formed to balance the throws and also the big end of the connecting rod. Fine balancing is done by drilling out or adding small weights. The crankshaft rotates in the engine on journals, which run in bearings called the main bearings. The connecting rod, with its big end bearings, is attached to the crankshaft crank pins located on the throws. Drilled passages carry lubricant under pressure from the main bearings to the adjacent big end bearings. The rear of the crankshaft is drilled and tapped for flywheel attachment. Near the front of the crankshaft, a timing gear or sprocket is attached to drive the camshafts. A drive pulley is mounted on the front of the crankshaft. It drives many components, including the alternator, the fan and water pump, and power steering. Many inline and V engines have a harmonic balancer attached to the crankshaft. The harmonic balancer is more correctly called the crankshaft torsional vibration damper. It prevents crankshaft vibration. In most cases, the harmonic balancer incorporates the drive pulley. This section examines camshafts and drives. The position of the camshaft depends on the design of the engine. It can be in the engine block, close to the crankshaft. This is called a pushrod or overhead valve system. Or there can be one or two camshafts mounted in the cylinder head. But in both designs, it does much the same job, driving the valves and the distributor, and sometimes the fuel pump and the oil pump. The camshaft is made of hardenable iron alloy or steel, and it can be cast or machined. The cam lobes are ground to the proper shape and position in relation to one another. Accuracy is crucial. If the cam is not exactly the required shape, or if it becomes worn, there can be impacts, fast valve wear, or noisy operation. The bearing surfaces on the camshaft are ground smooth, and the distributor drive gear is machined into the shaft. The cam lobes are then flame or induction hardened. The camshaft has a cam for each valve. In some cases, there is an additional cam, known as an eccentric, to operate the fuel pump. A gear on the camshaft drives the ignition distributor and often an oil pump. In modern engines, the pushrod system is being replaced by the simpler overhead camshaft arrangement. The overhead camshaft is located in the cylinder head. There can be one or two camshafts. Let's look at a single overhead camshaft arrangement. Single overhead camshafts can use rocker arms. The cam can lift one end of the rocker arm, or it can press down on the rocker arm. On double overhead camshaft systems, the most common arrangement is to use a bucket tappet or lifter. It operates in a guide that protects the valve against side thrusts, which it would receive if the cam operated directly against the valve. The adjustment of valve clearance is usually done by changing accurately machined spacers. Spacers are available in a range of thicknesses, and they're exchanged to obtain the correct clearance. Some overhead cam engines use a hydraulic lash adjuster to reduce lash in the valve train. They have zero clearance at the valve stem, so there's no need for tappet adjustment. It can be put in the valve end of the rocker arm. Like the hydraulic valve lifter, it has a body with plunger held against the valve stem by a spring. Oil supplied to the adjuster keeps the plunger in contact with the valve and eliminates lash. Lash adjusters can be put in the cylinder head at the end of the rocker arm. The lash adjusters are stationary and have a pivot for the end of the rocker arm. The plunger in the adjuster holds the rocker up against the cam. In the lash adjuster inside the bucket tappet, the plunger's hydraulic action holds the bucket body against the cam on the camshaft, and also against the tip of the valve stem, so that there is zero clearance.